Hello and welcome to this Functional Skills Maths Level 1 and Level 2 course video on measures, and this particular video is about time. The learning outcome for this video is to know the number of hours in a day, days in a week, months and seasons in a year, and so on. And you need to be able to name and sequence these different lengths of time. The linked learning for this video is that in previous videos we've dealt with numbers and place values, and the numbering system we've used so far has gone in groups of 10, 100 and 1,000 and so on. Now the units of time that we're going to cover in a minute will have different groups. In other words, you go up to 60 for 60 seconds in a minute. You go up to 24 for 24 hours in a day. So the number of groups of numbers to move to the next place value is not 10. Now, most of the units that we use for time come from two distinct areas. The first is the planets and the rotation of the Earth and the Earth's rotation around the Sun. And this gives us many of our bigger units, like the number of days in a year, and it gives us our seasons. The other area where our units come from are from ancient times, so mainly from the Greeks and the Romans, and that's how we get our number of days in a week and the number and the actual names of those days. So let's have a look at some of these groups then. So the seasons in a year are spring, summer, autumn and winter in that order, and they come from the tilt of the Earth. So the relative tilt of the Earth relative to the position of the Sun gives us our 4 seasons. The number of days in a year also comes from the length of time it takes the Earth to rotate around the Sun. Now, a lot of people assume that there are 365 days in a year, but there are in fact 365 and a quarter days for the Earth to rotate around the Sun. So every 4 years we gather these 4 quarters and we call it a leap year. Which has 366 days. So there are 365 days in a year, except for a leap year, which has 366 days. And that's when we add February the 29th. Again, the number of hours in the day is relative to the length of the time the Earth takes to rotate. So when the Earth rotates 360 degrees, we've decided to call that 24 hours in a day. Now, the number of months and weeks in a year is set by old religions and gods within those religions. So the 12 months in the year are January, February, March, April, May, June, July, August, September, October, November and December, and they come from various gods, those names. So there are 12 months in a year. We also know that there are 52 weeks in a year. However, the number of days in each of the months, and therefore the number of weeks in each of the months, may vary. We also know that there are 7 days in a week. So we also know that the names for the days in a week, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday and Sunday, those names also come from ancient gods. Now, There is a question that comes up quite frequently in functional skills where they test your understanding of the number of weeks in a year and the number of months in a year. So here's a typical question. Rahila is paid £150 per week. How much does she earn in 6 months? Well, what a lot of people think is that 6 months is 6 lots of 4 weeks because they assume there are 4 weeks in a month, which is quite incorrect. So that gives you 24 weeks multiplied by the £150. So that would give you £3,600 as an answer, which would be incorrect because you're assuming there are 4 weeks in a month, and there aren't. Almost every month has over 4 weeks. So the way to address a question that involves 3 or 6 months is to halve or quarter the number of weeks in a year, because that doesn't change. So we know there are 52 weeks in the year. So if we divide this by 2, we end up with 26 weeks in 6 months. And this will give you a more accurate answer. You see, it's not 24 weeks, it's actually 26 weeks in 6 months. Therefore, 26 times 150 gives you the correct answer of £3,900. So be aware when you do questions that involves being paid for a number of months that you don't use 4 weeks in a month, because there is more than 4 weeks in almost every month. So try and use the exact number of weeks by using the number of weeks in a year. Another popular question in functional skills maths is questions where you have to use calendars, and they quite literally will give you a calendar. So be prepared to be able to manipulate a calendar and go forwards and backwards from a date using either days or weeks on a calendar. Let me give you an example of how this works. So a question could be along the lines of, a garage is open every day except for Sundays. If you want to take a holiday from the 14th to the 28th of July inclusive, how many days must you use of your holiday entitlement? So the word inclusive means I want to take a holiday on the 14th and the 28th. So I want to take this day as a holiday and this day, and I need to work out how many other days I need to take on a holiday. So we can use our calendar that they've given us to show our working out. So we don't work Sundays, so we can cross the Sundays off that would be involved in our calculation. Then we need to work out how many days we're going to take for holidays, so we can put a tick on each of the days we're going to use. Now, using our calendar, we've got our inclusive dates, we've got our Sundays that we've crossed off. We can now count the number of days we need to take for our holiday. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we need to take 13 days holiday to have the 14th to the 28th off inclusive, but not including our Sundays. So can you see how you can actually physically use the calendar to show your working out how you get your answer? Now, with higher level dates and dates formats, there are lots of ways to write a date. You can write it out in full as the 25th of January or Wednesday the 25th of January 2017. There's an abbreviated version, the 25th of Jan 17, 25/01/17, where the months are given a number, so January is 1, February is 2, and so on. Or you can separate them. Instead of using dots, you can use these tack marks to go 25 tack 01 tack 2017. And you'll see various formats of dates in various documents, whether it's a bank statement, a letter from the council, Or when we used to write checks, you used to have to put the date in the top corner as well. So you'll come across various formats of dates in documentation. So please be aware of the various formats. You could receive them in any format. Now let's get to our lower level units of time, and that is telling the time in hours, minutes and seconds. And there are two main formats. There's the analog version, which are our clock faces, and the digital version that you're seeing on your mobile phones and a lot of your watches these days. First, let's look at the analog display. And an analog display will generally have the numbers 1 through to 12 on the clock cycle. And if you have an hour indicated on your clock, it will be a shorthand indicating the hours. So this is pointing at 2 hours. Now we don't know whether that's 2 in the morning or the afternoon, because there are 24 hours in a day, and that's 2 cycles of the clock. So if we have 2 o'clock, we need to find out whether it's in the morning, which is AM, or in the afternoon, which is PM. So if it's in the morning, we say AM, because that stands for ante-meridian, in other words, before midday. And if it's 2 o'clock in the afternoon, it's post-meridian, because it's after midday. Now, because we have 12 divisions on our clock face, when we come to annotate our minutes, we need to divide our 60 minutes in an hour by 12 to give us these smaller units. So now, when we annotate our minutes, so the minute hand tends to be longer than the hour hand, we know that pointing at the 5 isn't 5 minutes, it's actually 5, 10, 15, 20, 25 minutes. So our clock here is showing 2:25. And that can either be in the morning or in the afternoon. So we need to annotate it as AM or PM so we know whether we're talking about the morning or the afternoon. The other common format is the digital display. And there are two types of digital displays. Let's look at the 12-hour format initially. Now, with a 12-hour format display, the numbers on the hours go up to 12 only. But because of that, we have to distinguish between the morning and the afternoon. So they have an AM or a PM with them. So this clock here shows 9:24 AM. So 9:24 in the morning. This clock is 7 in the morning. And this one here is 1:45 in the morning. However, most modern clocks that have digital displays now use 24-hour formats. What this means is that the first 12 hours are 1 to 12, and instead of saying 1 in the afternoon, we add the 1 to the 12 hours that have gone already. So in this instance, if we take 12 away from the 13, it gives us 1:25 in the afternoon. So the time 13:25 is actually 1:25 in the afternoon. And this is a really common format these days for mobile phones and watches. So in order to work out what the time is, we can take 12 away from our hours. So it's 8:36 in the afternoon. That's what this clock is showing us. And finally, this clock over here, when you've got 21 as your hours, just take 12 away to give you 9, and that is 11 minutes past 9 in the evening. That's what this 24-hour clock is showing you. So we've established there are numerous ways we can be given time, or we can take the time and give it to somebody else. So on this clock here, on our analog display, we have 1:15. Now we really need to let somebody know whether that's in the morning or the afternoon. So it's 1:15 in the morning or 1:15 in the afternoon. The same for 1:15. I will see you at 1:15 in the afternoon or in the morning. If we're using our AM and PM annotation, this would be 1:15 PM and showing people that we're talking about 1:15 in the afternoon. Then finally, if we were using our 24-hour clock format, we could say this is 13:15. Because this is 1:15 in the afternoon, I add the 1 to the 12 that's already gone, and that gives me 13:15, and then I don't need the AM and PM. The fact that it's bigger than 12 is telling people it's in the afternoon. Now when we look at our lowest level of time units, we talk about hours, minutes and seconds. So we already know there are 24 hours in a day. We should know that there are 60 minutes to an hour and there are 60 seconds to 1 minute. So remember our linked learning. Instead of going round in cycles of 10 before we go up the unit values, with hours and minutes and seconds, we either go through cycles of 60 before we get to the next unit, or we go through cycles of 24 before we get to the next unit. Have a go at these and see if you can work backwards and forwards with our units of time. Don't forget to pause the video if you'd like to have a go. So let's have a look at these first ones. If I have 2 minutes and 20 seconds, what is that in seconds? Well, if I've got 2 minutes and I know there are 60 seconds in a minute, 2 minutes is actually worth 120 seconds. I've got to add this to the 20 seconds I've already got, so that gives me 140 seconds as an answer. So that's nice and straightforward. I'm multiplying my minutes by 60 to give me my seconds, and I'm adding the seconds I've already got. Now going back the other way to convert seconds into minutes and seconds is slightly trickier. You need to divide the 804 by 60, or find out how many lots of 60 seconds there are in 804 seconds. Now if I did this on a calculator, it would say 13.4. Now we're not really interested in the 0.4, we're interested in the 13. I know that 60 goes into 804 13 times, so I know there are 13 whole minutes. Now if I multiply 13 by 60, it tells me how many seconds there are in that 13 minutes. So there are 780 seconds in 13 minutes. Now I've got 804, so I take away the 780 that makes up my 30 minutes, and that leaves me with a remainder of 24 seconds. So we end up with 24. So 804 seconds is the same as 13 minutes and 24 seconds. Now let's look at hours and minutes. How many minutes are there in 16 hours and 20 minutes? Well, I know there are 60 minutes in an hour, so I need to multiply my 16 by 60, which is 960 minutes. I've got another 20 minutes here that's already in minutes, so that gives me 980 minutes in my 16 hours and 20 minutes. Now let's go the other way. If I have a lot of minutes, how many hours and minutes does that make? Well, it's the same as before. I need to take my 775 and divide it by 60 to work out how many hours I've got, whole hours I've got, in 775 minutes. And it goes in roughly 12.916 times. So forget about the decimal and just use the 12 to know that 60 goes into 775 times, 12 with some kind of remainder. So to work out how many minutes are in 12 hours, 12 times 60 is 720 minutes. We had 775, take away the 720, and it leaves you with 55 minutes. So 775 minutes is 12 hours and 55 minutes. Now have a go at these. So if I have 96 hours, how many days are there? Now remember, you're using a cycle of 24 for the number of hours in a day. So 96 divided by 24 gives me exactly 4 days. Now, if I have 10.5 days, how many hours is this? Well, I know that there are 24 hours in a day. So if I just take my 10 to start with, I know that's 240 hours. And if I have a half of 24 hours for that half day, I know a half of 24 is 12. So I end up with 252 hours in 10.5 days. Now, if you want to add or subtract two times together, in theory, you could use the column method, but it's quite complicated. Because when you borrow one from the next unit along, you're not borrowing a 10, you're borrowing a 60. So it can get quite complicated using our traditional column method. So the method we recommend for adding and subtracting time is what we call the step method. So if we had 3 hours and 46 and we wanted to add 2 hours 37, you would break it down in individual steps to make the maths easy for yourself. So what we could do is we could start by adding the 2 hours. And that would give us 5 hours and 46 minutes. Now, I know that another 14 minutes takes me nicely to exactly 6 hours, because 14 plus 46 gives me one of those 60 cycles, so I can add another hour. So I have 37 minutes, and I've borrowed 14 of them to get my neat 6 o'clock. So that leaves 23 minutes left. So now I'm at 6 o'clock, I can add my remaining 20 minutes to get 6:23 as my answer. Okay, let's have a go at moving time intervals. So if I have a time of 11:35 in the morning and I add 50 minutes to it, where does it take me? So start with your 11:35 in the morning and add 25 minutes initially to take you to 12 o'clock. Now, if we've got 25 minutes off our 50, it means we've got 25 minutes left to add. So let's add the 25 minutes to that. So we end up with 12:25. Now, we were at 11:35 in the morning, but as soon as you go past 12 in the morning, it becomes PM. So your answer should be 12:25 PM. So anything past 12 midday turns into PM. Let's have a look at the next example. We have 12:15 in the afternoon, and we need to take off 40 minutes. So let's do this in steps. Let's take off 15 minutes because it takes us to 12 quite neatly. So when we take off 15 minutes from here, it leaves another 25 minutes to come off. So 12 o'clock, take away the 25 minutes, leaves us at 11:35. Now this is the opposite. Because we were at 12:15 in the afternoon, as soon as you go earlier than 12 in the afternoon, which is 12 p.m., then it turns back to a.m. So your answer is 11:35 a.m. So let's have a look at our last question, where we're looking for a time interval between 7:25 and 8:05. So start with your start time of 7:25. Now the quickest and easiest thing to do is add 35 minutes to make it a nice neat 8 o'clock. And then we need another 5 minutes to get to 8:05. So our time interval is our 35 minutes plus our 5, which is 40 minutes. So our time interval between 7:25 and 8:05 is 40 minutes. This method of stepping between time is shown in your CGP books, and they are very common questions at level 1 and at level 2. So Ben sets off on a walk at 12:45 and he gets back at 17:25. So we're using our 24-hour clock method. So to work out the length of the walk, let's do it in little bite-sized chunks. So if you're at 12:45 and you add 15 minutes, you end up at 1 o'clock. If you add another 4 hours, it takes you to 5 o'clock or 1700. And then you've got the last little step to get to 17:25. So the time for the walk is 4 hours plus the 15 minutes plus the 25 minutes, which is 4 hours and 40 minutes in total. So it's the step method to work out the interval between two times. Have a go at this problem and see how you get on. So Danny needs to pick up his dog from the vet's. He's getting his haircut at 11:30 a.m, which should take half an hour. It will then take him another 35 minutes to travel to the vet's. What's the earliest time Danny should arrange to pick up his dog? So we're starting at 11:30 and we need to add half an hour. That's our first length of time. So that takes us to 12 o'clock. Then he needs another 35 minutes to drive to the vet's. So the earliest he can make the vet's is 12:35 in the afternoon. So don't forget, once you get past midday, the AM turns to a PM. So 12:35 is in the afternoon. It's a PM. Another one for you to have a go at. Ruth is going to watch a film at the cinema. The film lasts for 2 hours and 30 minutes. There is a 15-minute interval in the middle of the film, and if the film starts at 7:30 in the evening, what time should the film end? So we've got a 2 hour and 30-minute film, we've got another 15 minutes, and we have our start time of 19:30. So our start time is 19:30, and we need to add 2 hours first, which takes it to 21:30, and then the 30 minutes. So we end up at 10 o'clock in the evening. So that's our first chunk of time that we've needed to add. We need to add on the 15 minutes for the interval, so you end up with a film finishing time of 22:15 or 10:15 in the evening. Let's look at an exam style question. Ian is going to a concert. He decides to drive to the concert and back. The concert starts at 7:15 and it takes him an hour and a half to drive to the concert. He wants to arrive at least 10 minutes before the concert starts. What's the latest time he should leave home? So the concert starts at 7:15 in the evening. Now, we need to be there 10 minutes beforehand. So let's take that 10 minutes off to make sure that he arrives at 7:05 at the latest. Now, we've got 1 hour and 30 minutes we need to take off this time because of his journey. So let's break that down into hours and minutes. We know that 1 hour 30 is 1 hour and 30 minutes. So let's take the hour off. That's an easy thing to do. So 6:05 in the evening. Now we've got the 30 minutes to deal with. Let's just take off 5 minutes to make it a nice round 6 o'clock, leaving 25 minutes that we need to take off the 6 o'clock. So that's 5:35 p.m. So the latest time he can leave home is 5:35, and don't forget to put it in the format they've been using, which is p.m. And that's worth 3 marks. Now, something related to a fact we already know, which is there are 60 seconds in a minute and 60 minutes in an hour, means that we can talk about time as a decimal. We already know something from our fractions, and that's half of an hour, which is 60 minutes, is 30 minutes. We can also use a fact that we already know from our knowledge of fractions and decimals, is that a half is the same as 0.5. So half of an hour is also 30 minutes. So if we multiply what we call decimal time by 60, we can convert it into minutes. So 0.5 of an hour is 0.5 times 60, because there are 60 minutes in our hour. So the rule for decimal time, when you're talking in hours and minutes, and in minutes and seconds, is that if you want to come out of decimal time back to the smaller units, you multiply by 60. If you want to put something into decimal time, into the bigger units, then you divide by 60. So 30 minutes divided by 60 gives you 0.5 of an hour. So let's look at how we go in and out of decimal time. So if I have 3 hours and 24 minutes, the 3 hours is still 3. So the whole number doesn't change. Now, if you've got 24 minutes and you want to convert it into a decimal, so you're going from your small unit into your bigger unit, you need to divide it by 60. So you end up with 0.4. So 3.4 hours is the same as 3 hours and 24 minutes. 3.4 hours does not mean 3 hours and 40 minutes. Because we've got this cycle of 60, 0.4 of 60 is 24. Let's look at converting 5 minutes and 48 seconds into decimal minutes. Well, the 5 minutes stays as a whole 5, and the 48 seconds, to turn it into decimal minutes, you divide by 60. So you end up with 8. So 5.8 minutes is the same as 5 minutes and 48 seconds. Now, let's convert from decimals back into the smaller units. So if I have 2.85 hours, the 2 is still 2 hours. But to convert 0.85 of an hour, I need to multiply it by 60. So 0.85 times 60 is 51. So 2.85 hours is actually 2 hours and 51 minutes. Let's look at an easy one here. So we've got 5.1 hours. Now some of you mistakenly think that's 5 hours and 10 minutes, and it isn't, because 0.1 of a minute needs to be multiplied by 60. So the 5 minutes still stays the same. The whole number still represents the number of minutes. The 0.1 of a minute, and there are 60 seconds in a minute, means we need to multiply 0.1 by 60, which gives us 6 seconds. So 5.1 minutes is the same as 5 minutes and 6 seconds. So why do we need to know about decimal time? Well, some of the formula you're going to use at level 1 and level 2 means that when you put whole numbers into the formula, you're going to get decimal numbers coming out. Or conversely, you're going to need to put decimal numbers into your formula in the first place. Let me give you a simple example. The time a journey takes can be calculated by dividing the distance by the speed. So if I walk 17 miles at 5 miles an hour, how long will it take? So it's telling us divide the distance, which is 17, by 5. So when I divide 17 by 5, and you can do this on your calculator or manually, you get 3.4 as the time it takes for the journey. So that's in hours. Now, we don't in the real world say, oh yes, my journey took 3.4 hours. We tell people how many hours and minutes it takes. So the 3 hours doesn't change. Your journey still takes 3 hours, but 0.4 of an hour, which is 60 minutes, means you end up with 24 minutes. So my journey took 3 hours and 24 minutes, not 3.4 hours. Let's have a quick look at another one. The time to cook a chicken can be calculated by multiplying the weight in kilograms by 0.8. So how long would it take to cook a 3 kilogram chicken? So they're getting you to multiply 0.8 by the weight of the chicken, which is 3 kilograms. So you end up with 2.4 hours. Now, we don't talk like that, and there are no clocks on any ovens that work in decimal time. You need to put the hours and minutes into your timer. So the 2 hours is still 2 hours. Nothing changes there. But your smaller unit, 0.4 of an hour, needs to be multiplied by 60 minutes to give you your minutes. So 0.4 times 60 is 24 minutes. So your chicken needs to be cooked for 2 hours and 24 minutes. That's what you would set on the timer on the oven. Don't worry too much about getting practice with decimal time. When we come on to speed, distance, time calculations, you'll get plenty of practice with this decimal time notation. So that completes our learning outcome, which is to know the number of hours, days, weeks and months and seasons and so on, and to be able to name and sequence those. On top of that, we've looked down at the lower level hours, minutes and seconds and how to convert between those, and we started talking about decimal time. Okay, let's have a quick recap on our buzzwords. We know that a year is defined by the length of time it takes for the Earth to rotate around the Sun. And this is roughly 365.25 days. We know that there are 12 months in a year and that there are 52 weeks in that year. And these have been divided up by man and given names by the gods. So the months January, February, March, April, May, June, July, August, September, October, November and December come from ancient gods. So there are 7 days in 1 week, and those days, the names for those days come from Greek gods: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday and Sunday. We know there are 24 hours in a day and there are 60 minutes in an hour. There are 60 seconds in a minute, and we know that to come out of decimal time you multiply by 60, and to go into decimal time you divide by 60. The thing to be aware of is that when you're talking about months and weeks, try and use the fact that there are 52 weeks in a year. Lots of people think there are 4 weeks in a month, and there are not. That is the minimum that 1 month has, but the vast majority of months have more than 4 weeks in them. So try not to use that fact of 4 weeks in a month. And that completes this lesson on time. If you would like more practice or information on anything we've covered, then please talk to your teacher, who will give you any worksheets and additional information you might need. I hope you've enjoyed this video.